Hi guys, today we're going to go over the importance and basics of Inventor 2015. So to get this started, we need to observe Inventor and we're going to go through its workflow. And Inventor has a file-based workflow, and the first thing you have to remember is that you organize with projects. So your projects are up there in the Get Started tab. And now, as you can see, all your projects are named and labeled in the projects menu. And whenever you start a big new design file or system of files, you're going to have to make a new project. So let's just hit new and then get ready for a new project. So we're going to start with a single user project. You can also do a vault project if you want to share with others. And we're going to name this CO2 demo, because that's what we're going to be tackling in this video. Okay, that's good, and that's a good location. Click next. Now this is where the libraries. You decide to transfer over which libraries into your project. There's a list of available libraries. You click the arrow to transfer over. Okay, so now what's happening is we're going to change the active project. So you click on the project, then hit apply, and there you go. Your project is now selected as active. You can also, from this menu, create custom libraries, but we don't need to do that at the moment, so we'll just ignore that step. There's also plenty of other settings in the project menu if you want to customize your project even more. Down there you can see all the information in your project, like the workspace, the different libraries you use, and what is contained in each of those folders. And now we're just going to hit save and then done. So the first thing we have to know about Inventor are the different types of files it uses. So let's just go and make a new file up there in the Get Started tab. So here we can see all the file templates. The templates that we can use. We have the English, metric, and even mold design templates for the different measuring systems. There are 4 basic different file types. There are part files, assembly files, drawing files, and presentation files. So if we click on those different folders, if you look at it, it looks exactly the same, just they're organized for a different default measuring system. So we're just going to go back to the original template and start a standard part file. So we can begin our CO2 engine demo. So when you open up the part menu, it'll look like this, and this is your basic layout for a part file. And here we're going to start by going over and clicking Start Sketch. Okay, so when you click to the Start Sketch button, you're going to show up with this X of planes, and you're going to see all 3 planes, the XY, the YZ, and the XZ plane. So we're going to start our sketch on the XY plane. And here, let's just explore some of the things the sketch menu has. We can draw lines, just 2 points in space. And there we go. You can hit Tab to cycle through the options and the input boxes to set angles and lengths. And if you just keep clicking off, it'll create lines. And at the end, if you click and hold, you can create arcs. Then to finish, you right click and hit OK, or you hit escape. You can also select circles, make circles from center points. You can also make arcs from 3 points, so endpoint, and radius dimension. But there's more than that. As you see, most of these have drop downs, so you can do many other things that are just categorized under the same menus. So you can also make arc from center points, so it's the same concept of an arc, just a different method. And under lines you can do splines and maybe bridge curves. 2 different explorations of lines, they're a bit different. You can also make solid shapes like rectangles. You can make them out of 2 points or 3 points, maybe even a center point rectangle. You can also make slots, each 2 points in dimension. You can make slots with curves. Say you wanted to curve 2 lines. You can make a fillet and dimension those 2 lines and it'll auto curve them for you. just like so. And if you click on the endpoint, it'll do it directly for you. So you can also add text on your sketch to identify what you're doing and where. You can add sketch geometry, text geometry as well. So now we're going to start our actual CO2 engine demo. So this is the piece we're going to try to simulate. This is the crankshaft, and we can rotate around and see this is what the finished piece should look like. So you can rotate around by either clicking the little globe button or holding F4. So we're going to start by modeling the back of this piece. And let's begin. We're going to start with the base, since the base is the center of every piece. We're going to start with that. It looks, we're just doing approximates at the moment, so we know it stretches out and up. We're going to hit OK. And now, if we want to set dimensions, you can dimension it there. But before we dimension it, let's set up a center line. So we're going to click the little center line button and mark this as the center of our piece. Center lines help with dimensions in big parts. So we're going to dimension from the endpoint to the center line, and as you notice, it dimensions the whole piece. Since we're going from the center line, as soon as there's a mirror on the other side. This piece should be 0.831 inches. And now, I accidentally deleted the origin earlier, so ideally you would use the coincident constraint to reposition it at the origin. But that's not working, so I'm just going to drag it over. And now I'm going to lock this point so it doesn't move around anymore, using a lock constraint. Now next we have that curve, but we're going to do the curve right after we dimension this part to a 0.09 inch height. As you notice, this is a very small CO2 engine, so we're going to do a 3-point arc from that end to where we assume the other end is, and just stretch it out, since we're not really sure yet. We don't know all the arc dimensions, but we do know all the other dimensions. And we know that should stretch out. Oh, look, that's a center line. So that was accidental, because I still have center line selected. So if you click it, and then click center line, it'll turn off center line. But as you notice, I didn't unselect center line from the main menu, so this next line will also be a center line. So let's just make that not a center line, and then just remove center line altogether. Here. And now we're going to start dimensioning this piece so it looks more like it should. We're going to start by putting this arc tangent to this curve, to this line. And you use the tangent constraint for that. As you notice, a little tangent icon will appear. And then we're going to dimension the height. So from that point to that point. And that should be 0.65 inches. And as you notice, the whole piece changes in accordance. So our next dimension is going to be centering that point. So I'm going to do a horizontal point, and that'll change where the arc is positioned. And that should be 0.392. Whoops, 0.392. And next, we need to dimension that top line to be at the correct angle. So angle dimensions work with 3 points, but we don't have a third point to work on. So let's just make a construction line right up here so we can dimension the angle. Construction lines do not affect your overall item, so it doesn't matter how many we make if they're construction. So let's just make an angle dimension, so 3 points, with the angle being in the center, and that should be a 30-degree down slope. And there we go. So next, I'm going to try to make that perpendicular. Oh, I over-constrained it, so I'm going to try something else. So let's just make sure those two are aligned. And that looks about right. All we've got to do is a couple more things, and this piece should be ready to go. So let's just dimension that height. It should be 0.813, and that'll reset our arc. And now all we have to do is make sure that that flattens out in tangents. Now, what I'm going to notice here is that I did not make this correctly. This line will not be able to successfully work, since there's no possible way for this curve to be tangent to an imaginary line right there. So as it'll obviously tell us. So what we're going to have to do is delete it and make a new one, because I've realized now there should be a tiny line across, and then there should be the curve. So let's just delete this curve and skip to that. So here I'm placing an endpoint where the curve should start. That'll be the same dimensions that we originally had. And then I'm going to use an arc by center point to find the right dimensions. And if you notice, it won't work that way because it still dips below. So I'm going to start from above and then go down until it is perpendicular. There we go. Oh, whoops, that is still a construction line. So I'm going to unselect construction line and do it one last time. And starting from the endpoint there, and it'll show a little imaginary line telling us it is that it is tangent. So let's just stretch that across, and there we go. That should finish the curve. Now if you notice, we only have half of our desired shape. So what we're going to do is we're going to select all of our shapes, all of our lines, and use that. All you have to do is click and then hold shift, and when you hold shift it'll multi-select. Whoops, that was caps. So let's hold shift to multi-select, scrolling in and out using the wheel to find those hard to reach places. And once you select everything minus the center line, you can use the mirror command to copy that whole thing. So we've already selected everything. So now let's select our center line as our mirroring line. Hit apply, and there we go. It's our exact shape. So now that's what the base should look like. And that's all we have left to do, is extrude this into a solid shape. And hit finish sketch, and now we can start that process. And that process will start with the first step called extruding. Okay, so we're going to click extrude, and it'll select the first solid profile, and that will be our sketch. And if you can notice, it shows a projection, and you can manually manipulate it to show how far you want it extruded. But in this case, we know we want it 0.6 inches, so we're just going to do that, hit OK, and that is our complete shape. But there's one thing that's different from the original model, is it's gray and not silver. Well, that's because it's still the generic type. So there are two drop-downs at the top. That is the default, the appearance drop-down, and the material drop-down. So we're just going to click the one on the left, which is the material drop-down, scroll up and select aluminum, and it'll turn silver because it is aluminum, just like the original model. If you notice, by clicking the view cube and the home button, we can manipulate what we're looking at. And if you also see, we need to create that circular cut into the piece. So we can either click the start from new sketch onto that face, or we can right click the face and create a new sketch right from there. So we know that we want to create a circle. So we're going to make a circle in the center here. And inside it should be a circle of radius 0.25 or diameter 0.5, and we're going to vertically constrain that circle to the midpoint using the vertical constraint. And then we're going to dimension that height to, it should be 0.294. So let's click the center point of the circle in the bottom of the part and reconstrain that, redimension it to 0.294. And that looks exactly right. All you gotta do is hit finish sketch, and it looks like that. So now we're gonna hit extrude again. But this time, if you click on the surface, it'll pop out, but we want it cutting in. So you click on that button, then you click cut instead of join. You can see it's once again manually editable. but we're gonna just type in our distance. It should be 0.54 in. There we go. And it's not all the way in, but it is most of the way in. And that's exactly what we want it to be. Now the next thing we have to do is add holes on this face. So we're going to right click this face, click new sketch, but instead of drawing circles and extruding them, let's do them a different way. Let's do it with points. Points in the hole command. So let's put 4 points, 4 around the center point, just like this. And now, see that line showed up, so we can just right click and delete it. That's my bad. So let's dimension this center point. The center of this big hole should be 0.25 away from the side. And when we originally placed it, we saw a little dashed line showing up from the edge, telling us it was in the midpoint of that side. So we're safe on that dimension. It auto-constrained it there for us. So let's just constrain this side point to 0.07. Whoops, 0.07, not 0.7. Okay. That looks a bit better. And instead of doing the rest manually, let's just do them using a pattern command. So we will just repeat a geometry over a different set of distances and directions. So let's just delete those and hit rectangular pattern. So that's our geometry. Our first direction is that way, and we want it a total distance of 0.43 away from the side. So we're going to do that minus the distance of the first point, so minus 0.07. There we go. And then hit our direction 2. To make it go up, we want to go the same distance. So let's just copy, Control C and Control Paste over to the other one, and hit OK. If you notice, those centers seem a little bit off. They seem a bit too close to the edge. And that's because I forgot to constrain the first point to the bottom side. But that's okay, since no matter what we do, if we edit that first point, the whole pattern will change with it, since they're all constrained to each other. So let's just dimension that first point to the edge at a distance of 0.07. Hit OK, and now the whole thing went down. That's exactly what we want. So now that we have a sketch depicting the locations of the points. So we're going to hit Finish Sketch, and then Command and start some holes. Using the hole command, I'm just going to immediately select From Sketch as default. If you notice, that's not at all what we want it to look like. We want it to look with tiny holes. So the holes are actually 3/64 diameter. And there we go, that looks better. But we don't want that center hole to be 3/64. So we're going to select center and unselect it. And the distance is not through all, it is a distance. So we're going to manually manipulate that instead of inputting a distance this time. So it goes through the top, but not all the way through the inner part. And that looks right. So let's just circle back around to make sure that looks right. By dragging the corners on the view cube, or by holding F4. This time we'll drag the view cube. And that should be fine. We're just going to click OK. And now, if you notice, we can put another hole on because our sketch has been consumed. So we're going to expand that. Right click Sketch. If you notice, it's not visible. So let's click Share Sketch. It's immediately visible again. It's also manipulatable in different options. So let's click Hole. And this one's 0.25. But it's not actually 0.25, it's 0.375. So if you ever make a mistake like that, all you have to do is right click on your thing, hit Edit Feature, and then re-edit it in there, and it'll manipulate it and change it to how it should be. Now our sketch is still visible since we shared it. So let's just right click and change visibility. And now it's off. And we can use F4 to orbit the piece. And let's just explore all the other options we can do in a part. you can do a revolve, which is revolving a profile around an axis, or you can extrude a profile along a line, or you can make holes or fillets. And fillets are just like the sketch fillets, except they're in 3D model form. And when you do it that way, you can manually manipulate it, or you can shell the piece, or even combine different solids together. And if you're ever not sure what any of these commands do, if you hover over them, they will expand and show you visual representations, either in a GIF or in a series of pictures that depict the command. So, and that's all we need. That's all we need from this part and the part files. Anything else, you can just look through the different tabs. So here's the completed part. I went through the liberty of completing this on a earlier date, and completed this so you can see what it should look like. And now let's put all the pieces together in an assembly file. So you can either go into the Inventor menu and then go to New Assembly File, or you can even click that little icon up there in the Quick Access toolbar and click Assembly. This is what an assembly looks like. There's nothing in here, since you have to place pre-created parts from part files into an assembly and join them together. So these pull directly from your workspace, which is associated with your project file, which is why you need to make a project. So your first part should be your base part. You can make multiple iterations, but you can just hit Escape or right-click OK to keep whatever parts you want there at the moment. And so that's our first part, and let's add some cylinders to this CO2 engine. So if you click on a piece, it'll show you the icon, and you can look for the pieces you're looking for. And that's the piece I'm looking for. So I need 2 of them, one for each side. Need 1, 2, and I can right-click OK, just like I did earlier, except using Escape. So now there are 2 basic controls in the assembly file. There is joint and constraint. Joints help create relationships between parts, and that way they can be manipulated and modeled. And constraints help you further increase those relationships. So right now I'm going to just click on that, click on the outside ring of both. Your first part being your moving part, your second part being your stationary part. It automatically suggests a relationship type. So it suggested rotational, so we're going to go with that. So we're going to do the same thing to the other one, rotational. And let's say we didn't want it to be rotational, we wanted it to be rigid, so it wouldn't move at all. Well, that's that. And now you see it doesn't move. But now our base part is moving, so let's right-click the base part, click ground, so that way it won't move. And you notice that this piece is rotating because it was a rotational. Well, we technically should have put it as rigid, but instead of editing it, let's just add a constraint. So we're going to constrain the center axis to that center axis, and now it will no longer be rotational. It'll be rigid, if you notice. And now, there we go. That's what we want. But if you notice, that's not really the ideal viewpoint for this. Or at least I don't think it'll be the ideal viewpoint. But let's just keep going and adding more parts, and then we'll see what a good viewpoint is. So let's look for new parts to add. No, maybe we should go for the bushings. Well, the crankshaft. Let's add the crankshaft. So let's add the crankshaft, but to add the crankshaft we need bushings. So let's look for bushings. Or bearings. And let's add 2 bearings. And now what we're going to do here is we're going to joint the bearings into place. So the outside of that to the outside of that. And if you notice, rotational constraints only give us 1 degree of motion. But we need 2 in this case, since they're not completely centered. They're a bit offset. So that might look right. That gives us extra ones. That gives us an extra one. That gives us an in and out motion. But it looks very similar to slider, doesn't it? Well, before we click yes, let's zoom, let's hover around and select it again so we can see that little animation. And there we go. Slider. You see that doesn't move the right direction, so we're going to have to go with cylindrical. Then you're going to hit a plus so we can add another identical constraint. Joint. So do that to the other bearing. Pop it in place. And it should be cylindrical, yes. Good. We'll hit check mark. So now if you notice that those are movable since they're cylindrical. They can move in both of their allotted ranges of motion. But those aren't in place yet, so let's constrain them into place. So what we're going to have to do is flush the edges. So we're going to want to flush that front edge together, but make it slightly offset by 0.1 out of the piece. If you notice, I went in, so we're just going to make it negative direction to make it pop out. Hit apply, so that way we can add more constraints. Pivot around, and then flush those back faces. Once again, using F4 to manipulate. And that does the same thing. It pops it in, so negative direction to pop it out. And there we go. So now we're going to want this crankshaft to be put into the piece. So we're going to joint that part to the inside of this part. And it should be able to rotate. So let's do that. Good. So if we look around, that's what it looks like at the moment. And we can rotate this part. It's not very visible right now, but let's turn it around and you'll be able to see it. We can rotate. There we go. And now let's go home. But if you notice, home isn't a very ideal position. So let's just move around the view cube and try to find a good place for our default view to be. And that's better, so let's just start manipulating from there. Let's do that top corner. So this can be done in any file. You just right click that edge on the view cube and then set current view as home. So that way you can set your ideal view as the one you set to home. So now we're going to place another component in. Let's place the next component, and I don't know, let's make it a flywheel. So the flywheel is what connects to the crankshaft, but if you notice, not in the correct orientation. So instead of orientating it later in the process, we can do it now by right-clicking and using the placing commands, by rotating it about the little directional axes we get when placing the part. And then we can right-click, hit OK, pivot around, and now we could join this kit together, but let's use constraints so we can see other types of constraints. So first we're going to constrain the axes, and then let's flush those faces, mate those faces, so that way the faces touch and will always be touching. They're not aligned horizontally, they're contacting. But actually, that was a bad idea, so I hit cancel, and now we're going to flush those faces. If you notice, you can spin the flywheel. When you spin the flywheel, the crankshaft doesn't move like it used to. That's because they're just constrained together. They're not motioned together like a joint would do. So to fix that, you go into constraints, go to motion constraints, and you pick your first one, and then you select your motion type, then your second object, and you hit apply or OK. Apply is if you want to create another constraint. So now let's try that. If we spin it counterclockwise, the crankshaft goes clockwise. That's not right. So let's expand it, try to edit our constraint, and that's because they weren't aligned the correct direction. So we change the direction. Now that should work. As that turns as well. And that's pretty much the basics of assembling a part. And I've gone about the liberty of completing it. Granted, the parts have changed colors for easier visibility, and eventually everything can be put into an identical relationship, like so. And as you see, as you turn the crankshaft, everything moves inside. And there are other things to explore in the assembly tab, and you should be able to do that on your own, because those are a bit more complicated. So thanks, and hope you enjoyed it.